Our next example here involves variable expressions for all three sides. But the pattern is still the same. We still have shorter sides. The shorter sides here and here, which are around that right angle. The right angle is always opposite the hypotenuse, by the way. So this side over here, that always is C. It actually doesn't matter which of these we call A and B, because it doesn't matter how we add those. Addition is commutative, remember. But what this means now is I have some more complicated, I get a more complicated equation. What I have is the square of 5x plus the square of x plus 5 equals the square of 6x minus 5. This is my initial setup for this particular equation. Now be careful of something here. This is not the same thing as x squared plus 25. These are not equal to each other. This is not how this works. We can't distribute a square. That's not a coefficient, that's a power. This x plus 5 squared means x plus 5 times x plus 5. So we have to do the double distribution. We have to multiply the x times x plus 5 and then the 5 times x plus 5. Now if you remember back several videos, if you just go back to the factoring chapter, there is a shortcut that we can use. There is a shortcut that we can use for perfect square trinomials. You might remember this. Anytime you're adding two things, you have the square of a sum. That's a squared plus 2ab plus b squared. And if I have a minus b, the square of a minus b, well that's a squared minus 2ab plus b squared. Use the shortcuts if you remember them, or use the longer process if you don't. This, of course, we get 25x squared. That's as it is. This thing here, though, we get x squared, so that's x squared plus 5x plus 5x plus 25, so that's x squared plus 10x plus 25. And just to shortcut this process and go straight to an answer, we get over here 36x squared minus 60x plus 25. You can do that in your head, because 6x squared, or the square of 6x, I should say, is 36x squared. The square of 5 is 25. 6 times negative 5 is negative 30. Double that, as we do down here, and we get negative 60. Negative 60x. We have a quadratic equation. What do we need to do? We've got to get it equal to 0. I'm going to have to move everything to one side. First, I'm going to combine those like terms to get 26x squared plus 10x plus 25 equals 36x squared minus 60x plus 25. And I'm going to just minus 26x squared from both sides. And that gives me 10x plus 25 equals 10x squared minus 60x plus 25. Now we'll go ahead and minus the 10x, and you know what, I'll just minus the 25 from both sides as well, minus 10x from there, minus 25. I'm going to rewrite that just to give myself a little bit more room to work with. So I get 0 on that left equals 10x squared, should give myself a little bit more room actually. 0 equals 10x squared. Negative 60 minus 10x is negative 70x, and then 25 minus 25 is, well, 0. So we get this. Now I factor. Nice thing here, I take out a GCF, and that's the only factoring I have to do. 0 equals 10x times x minus 7, which gives me solutions x equals 0 or x equals 7. And just like we had in the previous video, you got to be careful, because not every solution will necessarily be valid. If I use 0 for my sides, then I get 0 there, I get 5 there, and I get, what? 6 times 0 is 0, minus 5 is negative 5. And I don't think that works. For one thing, I can't have a side that's 0 long, and I certainly can't have a side that's negative 5 units long, so this doesn't work. This solution we have to get rid of. So it's the 7 that we're going to keep. So x equals 7 That's part of the solution, but keep in mind that's not the whole solution, because ultimately I want these three sides. So what I want is the sides. And so the three sides in question, the variable expressions are 5x, x plus 5, and 6x minus 5. And so when x equals 0, we've already noted that that doesn't actually work. So when x equals 7, I get 35, I get 7 plus 5 is 12, and I get 6 times 7 is 42, minus 5 is 37. And those are perfectly acceptable sides. And you can check them, too. You could check this, and you should do that right now. 12 squared plus 35 squared equals 37 squared. We hope. Maybe. Yes. Hopefully. Check that. If it checks out, then we're good. Otherwise, you might have done something wrong. So check your equations. So if you still have problems, then ask your teachers, bring them in, bring your questions in. But otherwise, this is all just solving quadratic equations, really. It's a review, just in a new context.